All right, let me ask you something. What if you could build applications that don't just run, but they actually heal themselves? Well, welcome to Module 3. This is where we go way beyond just writing code. We're talking about architecting systems that are truly resilient, enterprise-grade, and can handle whatever the real world throws at them.
I love this quote. Code is a weapon, but the arena must be resilient. Think about it. Your code, it's like a finely tuned high-performance engine. It's powerful, right? A true weapon for innovation. But if you put that engine in a flimsy chassis, what happens? It's just a lot of noise and fury. This module, it's all about building that perfect machine, where raw power and rock-solid stability work together in perfect harmony.
So, how do we get there? How do we find that balance? Well, here's the game plan. We're going to start with the core conflict that, let's be honest, every single team faces. Then we'll dive into something called the complexity trap. It's what catches so many growing teams. But don't worry, we've got the solutions. We'll talk about the force multiplier of a modern platform, we'll build an architectural shield with smart design, and we'll even get into the chronicles of intelligence to make sure we capture all that wisdom we gain along the way. And finally, we'll put it all together to map out your path to mastery.
Okay, let's dive right in. First up, we have to talk about this fundamental tension, this constant battle that pretty much every single development team is fighting day in and day out. It can literally make or break a project.
So, on one hand, you've got what we call developer velocity. The business side is always pushing for more, right? Go faster, innovate, roll out new features. And then on the other hand, you have system resilience. This is what your users demand. They want things to just work all the time. Think about your favorite shopping site during a huge sale. You want the new deals, but if that site crashes when you hit buy, you're not just annoyed, you're probably gone for good. That's system resilience, and it is absolutely non-negotiable.
And this brings up the million-dollar question, doesn't it? Do you really have to choose? Is it always a trade-off between moving fast and, not breaking things? Is that just the cost of doing business? Well, the answer, as you're about to see, is a big fat no. Not if you have the right approach anyway.
Now this conflict, it can get out of hand really fast, and it often leads to what we call the complexity trap. This becomes a huge problem, especially when engineering teams start to scale up and get more distributed. You see, as teams get bigger, the mess just grows. Different groups start using different tools, you get this patchwork of inconsistent environments, and the cognitive load on developers just goes through the roof. What's cognitive load? Well, imagine trying to navigate a city, but you've been given 10 different maps, and they all contradict each other. That's what it feels like. You spend more time and energy just figuring out where you are and what tools to use than you do actually building the thing you're supposed to be building.
So clearly, we need a way to cut through all that complexity. And that brings us to the modern solution, something that acts like a powerful force multiplier for your whole engineering org.
And that solution is the Internal Developer Platform, or IDP for short. The best way I can describe it is, think of a perfectly organized, incredibly well-stocked workshop. Instead of every builder having to forge their own hammer and screwdriver from scratch, they can just walk in and grab a set of high-quality, standardized, ready-to-go tools off the wall. This lets them focus on what they're actually good at, building incredible things.
The real magic of an IDP is the leverage it gives you. It completely abstracts away all that complicated infrastructure plumbing, and it gives developers what's called a paved path. Basically, a standard, best practice, super efficient way to build, test, and deploy their code. This automates the whole delivery process, it bakes in governance and security from the get-go, and it frees up your developers to focus on what actually delivers value, building amazing applications.
Okay, so with that awesome platform in place, now we can focus on building what we call the architectural shield. Now, this isn't just one single tool. Think of it as a collection of battle-tested design patterns that make your applications not just scalable, but self-healing. First up, we decouple the architecture. The analogy here is perfect. Think of building with Legos instead of trying to carve something out of a single solid block of wood. When you break your big application into smaller, independent services, your Lego bricks, you can swap pieces out, add new ones on, and build way more complex things without having to tear the whole structure down and start over. Next, we have to design for high availability. This is all about hunting down and eliminating any single points of failure. So we deploy redundant components in different places, we use load balancers to spread the traffic around. The goal is, if one piece fails, the system just shrugs it off and keeps on running without anyone even noticing. And a key piece of this puzzle for both scalability and reliability is using a stateless architecture. Here's why that's so cool. When your application doesn't need to store session data locally, it means any server can handle any request from any user at any time. This makes it incredibly resilient. It can restart in a flash and scale out almost instantly to handle those crazy, unexpected spikes in traffic. And finally, we have to plan for those moments when things just get overwhelming. This is called graceful degradation, and it's all about failing smart. The perfect example is a streaming service during a huge live event. Instead of the whole thing just crashing and burning, it might temporarily lower the video quality a bit to keep the stream alive for everyone. That's graceful degradation in action. It prioritizes the core function to survive the storm.
So we've designed this brilliant system that can handle failure gracefully. Awesome. But how do we make sure that these smart, hard-won design choices are actually understood, remembered, and built upon by the next person, and the person after that? Well, that takes more than just clever code. It means we have to build a kind of institutional memory, a true library of wisdom.
And this is where something called Architecture Decision Records, or ADRs, come into play. Look, an ADR is basically just a simple document. But its power is that it captures not just what decision was made, but the really important part, why. It records the context, what other options were on the table, and what the consequences of the choice were. It's literally the story behind your system's design.
And the benefits here are just huge. New engineers can get up to speed so much faster. When it's time to evolve the system, you're not starting from square one. You've got all this historical context to help you make smarter choices. Honestly, ADRs are the perfect antidote to that dreaded phrase, I have no idea why we did it that way, but we're too scared to change it.
All right, let's bring all these pieces together. We've talked about the platform, we've talked about the patterns, and we've talked about the practices. So what does this all mean for you on your journey to becoming a true engineering master?
It's all about balance, right? It's about being able to wield the weapon of your code with amazing precision and creativity, while at the same time knowing how to build the shield of a resilient, scalable, and really well-documented architecture around it. This module is designed to give you both the tools and the mindset you need to totally master that balance.
So, welcome to Module 3. It's time to build systems that are truly built to last. The arena's open, and honestly, we can't wait to see what you're going to create.